Hello everyone. In our first video, we are going to discuss regarding introduction to VoLTE, and the agenda of this video will be voice services in LTE network, introduction to VoLTE, VoLTE radio bearer and QoS management, standards and specification, and LTE RAN features for VoLTE, and finally a brief overview of IMS. So starting from VoLTE. Why telephony in LTE? Why we require voice in LTE services? As all of you know that LTE is basically designed for high-speed data packet services, which was earlier available in HSDPA, but LTE enable us high speed even in case of the mobility. But what if we have to use our mobile device for voice call? In that case, either we need to or operator have to move back to the legacy networks for voice services. So it is quite complex and sometimes it requires extra hardwares as well. But there need to be a solution that LTE network can be used for voice services. Another than this is some of the service provider like Skype and Google were taking the revenue away from the operators by providing these services to the internet users. So this is very necessary to introduce voice services in LTE system as well. So voice services in LTE network is quite a challenge because for LTE existing we have no CS domain available. So how operator actually provide voice services to the LTE network is either by VoLTE, that is voice over legacy, connect the BSC RNC via PS domain to reach CS, dual radio UE, always register with the GSM UMTS along with the LTE-PS. But the disadvantage of this technology will be the UE battery will drain up very quickly, and then have a single radio UE, then we need to use a circuit switch fallback. CSFB is also known as a circuit switch fallback, and this methodology basically, whenever a CS call is required, the UE perform a fallback to the legacy network, either 3G or GSM, based upon the requirement and based upon the availability of network for the operator. So what will happen is after introducing these services, LD system can be used to overcome the top services or the top services like Skype and Google. So why we require VoLTE basically? So to introduce VoLTE, GSMA defined some standard for telephony solution that has been accepted by the operators community all over the world. GSMA has defined voice over LTE in permanent reference document number IR.92, describing the minimum set of requirement for delivering the voice in all IP environment based on existing IMS multimedia telephony solution. So this is a very simplified VoLTE end-to-end architecture where we have a VoLTE device which is similar to our LD device but have a support for VoLTE as well. Then we have a bearer defined to EPC volt packet core. Then we have a additional unit MMTEL, that is mobility telephony services application server or IMS. Then we have a world packet core at the other end, and in the same way we have a EU tran and into the N terminal of VoLTE device. A simplified version is just elaborated here, and this is a bit complex and detailed architecture of VoLTE system, where we have yeah, UE at this point, where we have a UE at this point, then we have E node B connecting to the MME, then SGW and PGW, and so basically in this complex architecture we can see that VoLTE is basically made up of EUTRAN, then EPC and evolved packet core, and addition of IMS. So by combining the EPS and IMS, we will get a complete VoLTE voice over LTE architecture. And the new nodes which have been introduced in this um, architecture, other than EUTRAN and EPC, are CSCF, ISCF, SCSCF, and MMTEL AS. MMTEL AS is here, and then we have MRFC, MGRF, IMS application gateway, PSCSCF, and these nodes are basically taken from the evolved packet core. Also, like PCRF, HSS is being taken from evolved packet core as well, but it has been introduced in IMS as well. And these are different terminating networks which can be either VoLTE itself or to PSTN or to other network as well. So now describing VoLTE bearers and QoS management. So in VoLTE we will have one new bearer. When we compare to the LTE, we need to have two bearers, but introducing VoLTE will introduce a new bearer, that is a voice bearer. So one of the bearer is very mandatory for IMS signaling, that is a signaling bearer, and once the signaling bearer is maintained or established, then at any time a UE can perform a voice call either in an originating site or in a terminating site. So once UE is connected to the LD network and have a signaling bearer at the IMS end, a VoLTE capable UE will always have a signaling bearer connected to IMS, and based upon the requirement it can establish these voice bearers and video bearers. And video bearers is basically can be established based upon the compatibility of the IMS. So these are new three bearers which will be added to the LD network after introducing VoLTE. So EPS bearer service architecture, and these are the different service architecture, end-to-end flows. EPS bearer is basically from UE to the PDN gateway. Then we have ERAP from UE to the SGW through PDN gateway, and radio bearer is only between UE to E node B. Then E node B to SGW we have S1 bearers, and all these bearers have a different QoS requirement. Now bearer management for QoS, as per the GSMA IR 0.92 PRD recommendation, voice media should always be mapped to a separate EPS bearer, as it is a guaranteed bitrate bearer. Other than this, SIP signaling, which is basically used from UE to IMS, should be protected against a congestion by being mapped to a separate EPS bearer with a highest QoS. We will see uh, the QoS and QCI mapping for different bearers, and which QCI and QoS will be mapped for SIP signaling will be important and interesting to see. Out of 256 QCI values, 9 of them have been standardized, and these have been specified by 3GPP um, reference document 23.203. Now this is the table I was mentioning earlier. We can see that we have a QCI type here, we have a resource type, we have a priority, and we have a delay budget. So for the guaranteed bit services, we have QCI 1 to QCI 4, then we have a QCI 5 with the priority highest. So QCI 5 is basically used for the IMS signaling, because we would not like to lose our IMS signaling bearer at any stage, because if we lose contact with the IMS, then it will be very hard to provide VoLTE services to the user. And these are other standard non-GBR from 6 to 9, which are basically used for voice and video streaming or for data streaming services. So the example, this is a layer 3 messaging from the time domain for bearer setup. This is a drive test log file from where we can see in the downlink DCCH RRC connection reconfiguration message. We can see that we have DRV identity 3. This is for VoLTE services. We can see that EPS bearer identity 5, DRV identity 3, and then we have EPS bearer identity 6 and DRV identity 4. So EPS bearer 5 and 6 are basically standard bearer and IMS signaling bearer, which got set up in a single radio RRC reconfiguration. On the other hand, EPS bearer identity 7, that is a QCI1 bearer, got set up in the next RRC connection reconfiguration message. So as explained earlier, that QCI1 and QCI5 and the QCI 8 or 9 bearers are established in separate messages. So QCI 5 and QCI 9 will be reconfigured in one RRC reconfiguration message in the downlink, and QCI 1, that is EPS bearer identity 7, will be reconfigured or configured in a next downlink reconfiguration message. So now discussing about the standard and specifications. These are some mandatory LD feature which we should have in our system before claiming that we are ready to deliver VoLTE services. And then these features are QoS aware scheduler, RLC in unacknowledged mode, robust error compression, service specific DRX, and the details of these features will be covered in the different videos in upcoming sessions. So now talking about the standard requirements, we have radio capabilities which must be there, that is GBR IPS bearer QCI 1 for voice and non-GBR. We have a robust error compression and PDCP. We should have RLC acknowledged mode, unacknowledged mode, and LT DRX mode mandatory. Other than this, we should have SRVCC, and other than these are some IMS based feature, and these are some telephony services which should be available at the operator end, and these are the one highlighted in red, this one, and this one should are very mandatory features to initiate VoLTE. Alternate feature for QS scheduler, coverage capacity. So these are the features we have divided in different requirement for scheduling. We have QS aware scheduler, discontinuous reception. For coverage we have ROHC, that is rover serial compression. For mobility we have a single radio, voice call continuity. Then for regulatory emergency call support, and these are some friend feature with explanation. We will cover these in detail in next sessions. Now, introduction to IMS. What is it? IMS is IP Multimedia Subsystem, is an architectural framework first designed to deliver IPPS services in a mobile telephony system, later designed to simplify the deliver multimedia services over IP. The idea behind IMS was to merge the environment of a telecom and internet and provide services on a single platform. To ease the integration with the internet, IMS uses Internet Engineering Task Force Protocol, that is SIP, Session Initiation Protocol, for control signaling, and Real-Time Transfer Protocol for media handling for delivering audio and video over IP network. So IMS offer multimedia, multi-services, multi-access, multi-technology. So IMS play important role not only in VoLTE but also play a very important role in PSTN modernization, fixed mobile convergence. It's a rich communication suite to enhance enriched communication service for mobile and fixed user as well. So all these services, PSTN, mobile, VoLTE, fixed lines, all these services can be connected on a single platform, that is IMS. So this is a very simple architecture of IMS as described earlier. We have some support systems, we have some application servers. MTAS is basically used for VoLTE. Then we have a PGM and SCC application server. Then we have IMS core. In IMS core we have HSS, and we have SPG session border gateway. We have ICSF and SCSCF, and we have some other units as well. Then for the interconnection to other networks, we have a session border gateway, we have MRS, we have MGC. So this is a very basic architecture of IM. Talking about the SIP signaling, SIP as described earlier is a protocol suite used for signaling in IMS, and it's application layer signaling protocol. It runs on TCP, UDP, or SCTP. It has been deployed and defined by Internet Engineering Task Force. So that's all for today's session. In the next session, we will cover the mandatory features for VoLTE. If you have any comments, any suggestion that need to be, included in the videos, please put your comments below. Thanks a lot. See you soon.